Hi, this is Roman, and today we're doing Unit 8 on conditional probability, Day 21, probabilities in games, with our focus question of how can we determine independence of events and estimate conditional probabilities using data collected. So I'm going to be going through a few of the questions here, starting from slide 11 on softball, and I'll be doing it in my Google Jamboard here. So as we read our first question on softball, we are told that the two-way table summarizes whether or not a softball team had practice when it was raining and when it was not raining at the start of the day. So let's take a look at our first question here. Our first question is, when it was raining at the start of the day, what is the probability that softball practice was held? So if we take a look at when it was raining, right, and what I'm going to do is I'm going to create some totals here to make things easier for me. In my raining column, I have 5 total outcomes here, and I see that when it was raining, we held it 4 times out of the 5 total possible outcomes there, right? And if I continue this trend here and I make my totals, right, I'm going total across each row, total for each column, and then I have a total for everything that happened here on the bottom right. So let's take a look at question B. When it was not raining at the start of the day, what is the probability that softball practice was held? So taking a look at when it was not raining, and I'm going to do this in blue so we can differentiate it here. So it was not raining. Softball practice was held 12 times, right, out of the total 15 times in this case. And we could divide top and bottom here, looks like by 3, and we would get 4/5. So for C, it's asking, are the events of holding softball practice and raining at the start of the day independent events? And to explain our reasoning. So based on A and B being equal, and it might go against our intuition, we would say that they appear to be independent, right? Because when it was raining and when it wasn't raining, we had the same probability of holding softball practice. So we are allowed to say that they appear to be independent. Now, I'm going to move on at this point to one more sample. So if we take a look at our lesson here, I believe this is slide 13 as we're continuing. And again, we're having these tables that we're working with here. So in this question, we're told that the two-way table shows the number of eggs laid by 10 Rhode Island red chickens and 10 Leghorn chickens in July and August. And now we have our 2 events here. So we have event A as a egg laid by a Rhode Island red chicken, and event B is an egg laid in July. So let's find the probability of A here. So the probability of A is an egg laid by a Rhode Island red chicken. So again, for these purposes, I'm going to want to add up my probabilities for a Rhode Island red chicken. So I have 247 and I have 252. If I add those up, I will get 499. And my total in this case for all the probabilities is 1979. So my probability of A would be the total 499 for the Rhode Island red chickens laying an egg over the total of 979. And if I do this, I would get about 0.5097. And I'm going to round this to the nearest hundredth. So we could say approximately about 0.51 or 51% of the time. Let's take a look at the probability of B, or event B. An egg laid in July. So let's use a different color ink here. And if we take a look at what happens for eggs laid in July, right, we'll see that if we add up 247 and 239, we're going to get 486. So that would be 486 over 979. And this is going to give us, let's say 0.4964, or approximately we could say 0.50, or 50% of the time that's happening out of our total. Now for C, we're doing the probability of A and B, right? And we should know that this is the probability of A times the probability of B, right? So what are we doing here? We're doing 0.51 approximately times 0.50. And this is about 0.255. So now let's take a look at how we might use our Desmo Scientific Calculator to do this as well. So if I go to my Desmo Scientific Calculator, right, and I want to show all these probabilities that I might be able to do in my calculator as well. So the probability of A was 499 over 979. And I see here, I see this decimal, and I rounded it up to about 0.51 for A, the probability of A. And we'll see that here, if I turn it into a fraction, it just gives me the original fraction that I had. So it's not very helpful in simplifying because it is the original that I entered. Now for B, to verify my answer for B, again, we would type in 486 over 979. And we get approximately 0.50 if we're rounding to the nearest hundredth here. And then for my last one, right, I rounded, I did 0.50 times, actually the first one was 0.51 times 0.50, right, and I got this 0.255. But what if I didn't round, right? What if I didn't round? Because I have Desmos here, I could definitely do the full thing. I could have done 499 over 979, and I could have multiplied it by the actual probability. So no rounding here, but let's see what happens. What was our error in rounding? So I still get approximately 25%, but I'll see it's not 0.255. In this case, it's 0.253. So a small error, but we would say that the probability of A and B would be about 0.255. So these are a few samples of how to do the following probability questions given tables, and I hope we found this useful.